Hey everyone, so in this video we are going to be looking at some examples working with regular expressions, and before we jump into that there's a bit of notation that I want to make you familiar with, and this is something that you might not see everywhere, which is why I want to make you familiar with this. The first thing is I have a habit of writing a plus instead of a union. So if you see me writing something like a 0 plus 1, that just is equivalent to 0 union 1. So that's one thing. The second thing you might see me writing is instead of the cleany star, I sometimes use a plus. So if I say something like 0 plus, that just means it's a 0 concatenated with a 0 star. Now, the reason this is actually useful is because when I say 0 plus, it helps me say that there needs to be at least one 0 there, and there could be as many after that as you want. But the problem with a 0 star is that it could also just be an empty string, so I could have zero zeros there. So that's something that I want to avoid when I write 0 plus. So that's the second bit of notation. The third bit is I often use epsilon when writing my regular expressions, and that's just basically me writing phi star. So you might want to write phi star wherever I have epsilon, which is the empty string. So that's some notation that I wanted to make you familiar with. You don't really have to use this anywhere, but just for you to be able to follow these videos, I wanted to make you comfortable with these notations. So in the examples that we look at in the next video, remember that our alphabet is the binary alphabet, so it's 0 comma 1. This is our alphabet that we'll be working with. So let's go ahead and look at our first example. And one important skill that we need when working with regular expressions is to be able to convert English into regular expressions. So here's the English that I'm giving you. It says that give me all strings which have at most um, 3 ones. So this is our English, which we now need to convert to a regular expression over the binary alphabet. So let's just go ahead and give this a try. So it says it contains at most 3 ones. So what I can do is, let's say I do a 1 concatenated with a 1 concatenated with a 1, but then I realized that this is definitely going in the wrong direction, because it definitely said that it is at most 3 ones, which means that each of these ones need to be optional. So let's just go ahead to our next step, in which we do an epsilon plus 1 concatenated with an epsilon plus 1 concatenated with an epsilon plus 1. So I think with this we're going in the right direction, because we're saying that this one is obviously optional. You could instead use the empty string instead of the 1 here. So this is going in the right direction, but then I didn't add any zeros at all here. So what I might want to do is I might want to say, okay, there you go, there's a 0 star there, so just put as many zeros as you want, and then put either the empty string, so don't put anything at all after that, or put a 1 there, and then again you can do this 3 times. But then there's a problem here. So consider the string, let's say 0 1 0. Does this thing take care of that? And you'll realize that it doesn't, because once I've added this 1 right here, I don't have any provision to add a 0 at the end. So this is wrong. We need some improvement to that as well. So here's our next step after this. what we would do is we would say, okay, let's just add a 0 at the end as well. So I do an epsilon plus 1, epsilon plus 1, epsilon plus 1, and then let's just this is of course a concatenation, and then let's just do another 0 star here. So after you've taken any optional 3 1s, you can add as many zeros as you want. So this looks at least better than our previous one, but again consider let's say the string 0 1 0 1 0, let's say. Does this expression that we have, uh, can it actually make up this string? And you'll realize once again that it cannot, because we don't have any provision to have a 0 between 2 1s. So even this is wrong. And the next step that we need to do is our final step, which is just saying that even between R1s you can have as many zeros as you want. So concatenate this with a 0 star, concatenated with epsilon plus 1, concatenated with 0 star, uh, concatenated again with an epsilon plus 1, and finally concatenated with a 0 star. And this will actually take care of all my strings. So this one is the regular expression that I want, which corresponds to the English that was given to me. And one might say, what if I use an epsilon right here? Then you have a 0 star concatenated with a 0 star. Does that really make too much sense? And I would say that it doesn't make too much sense, because a 0 star concatenated with a 0 star is just a 0 star, because that's x number of zeros concatenated with y number of zeros. That just gives me x plus y number of zeros, and with this star itself I could have had x plus y number of zeros in the first place, because the star gives me liberty to have as many zeros as I want. So even though it might not make too much sense, but I'm well within my rights to do it. And this is actually something that's very much required, because I don't know if this epsilon is what's going to get chosen from this epsilon plus 1. So this is the regular expression that we've got from uh, the English that we were given. And let's just take a quick look at a slightly modified version of this itself. So our next example is me saying that it contains at most 3 1s, none of which can be consecutive, none of which are consecutive. I'm just going to leave it at consec. So these ones cannot be consecutive, which means that there needs to be a 0 between any 2 1s that I have. And at this point it becomes very useful to remember the notation that I told you about right here, which is this one. And all I'm going to do to my expression right here is I'm going to make these zeros, 0 stars right here as 0 plus. So what I do is I do a 0 star, um, sorry about that, a 0 star right here, concatenated with an epsilon plus 1, concatenated with a 0 plus this time, concatenated with an epsilon plus 1, concatenated with a 0 plus again, concatenated with an epsilon plus 1, and then concatenated with a 0 star right here. And if you want to not use this plus which I have used, you can always convert this thing right here to a 0 concatenated with a 0 star. That works as well. And one thing that I want you to take note of is not to convert either of these 0 stars to 0 pluses. And the reason you would not want to do that is because so let's say in this whole expression, if you just change this 0 star to a 0 plus, then you're also enforcing that your string needs to start with a 0, which is not mentioned in our English right here. So according to the language that's given to me, which is at most 3 ones, none of which are consecutive, this thing right here, a 10101, is a perfectly valid string according to the language given to me. But if I add a 0 plus here, then this becomes an invalid language according to the regular expression. So that's something that I wanted to point out. And these are just a couple of examples that I've taken. You might want to practice a bit more of these, because it's a very important skill to have, to be able to convert any language given to you in the form of a regular expression. And where this might come in handy is, let's say you're checking whether a string that a user has entered is an email address or not. You might want a regular expression for that, because there you want to enforce that there would be an at the rate symbol somewhere in it. So what should come before the at the rate symbol, what can come after the at the rate symbol, and then you would want to enforce um, a period as well. So things like that. So if I say email address, you know intuitively what an email address looks like, but to be able to convert that to a regular expression is very important. So you might just want to practice a bit more with maybe just binary alphabet, or if you want, you could practice with the Roman alphabet, which is A to Z. So make sure you are able to do that. And moving forward, we'll be looking at what more we are going to be doing with regular expressions. So I'll see you there.